A uniform magnetic field of 6.5 Gauss is maintained. An electron is shot into the field with a speed of 4.8 into 10 power 6 meters per second normal to the field. The radius of the orbit and frequency of an electron is. When any charged particle entering into magnetic field, it traces a circular path. Therefore, centripetal force is equal to QVB. Therefore, R is equal to mv by qb and n is equal to qb by 2 pi m. On substituting mass of an electron, velocity of an electron, charge of an electron and the given magnetic field in the relation R is equal to mv by qb, we will get radius of an orbit R is equal to 4.2 into 10 power minus 2 meters. To find the frequency of an electron n, we know that n is equal to qb by 2 pi m as we have discussed. On substituting these values again, we will get 18.18 into 10 power 6 heads. Ballistic demonstration: a police officer fires a bullet of mass 50 grams with a speed of 200 meters per second on soft plywood of thickness 2 centimeters. The bullet emerges only with 10% of its initial kinetic energy. What is the emergent speed of the bullet? The mass of the bullet is given to be 50 grams, means 50 into 10 power minus 3 kg. Velocity, initial velocity 200 meters per second. Kinetic energy can be calculated by using half mv square formula. The initial kinetic energy is 1000 joules. Since 10% of initial kinetic energy is wasted, Ke2 is equal to 10% of 1000, 100 joules. Let Vf be the emergent speed of the bullet. On making half mv f square equal to final kinetic energy Kf, we will get Vf is equal to under root 2 Kf by m. On substituting all these values, emergent velocity of the bullet is equal to 20 root 10 meters per second. The bob A of a pendulum released from horizontal to the vertical hits another bob B of the same mass at rest on the table as shown in the figure. If the length of the pendulum is 1 meter, what is the speed with which the bob starts moving? Neglect the size of the bob and assume the collision to be elastic. According to the problem, since the two balls are of the same mass, ball A transfers its entire momentum to the ball B on the table and the ball A does not rise. Therefore, the speeds are exchanged. Comes to rest and the bob B moves with the speed of A. The speed with which the bob B starts moving can be calculated by using the formula root of 2gh, root of 2 into 10 into 1, that is equal to root 20 meters per second, that is equal to 4.47 meters per second. A crane lifts a mass of 100 kg to a height of 10 meters in 20 seconds. The power of the crane is. Here the mass to be lifted is 100 kg. Acceleration due to gravity is given by 10 meters per second square. Therefore, power can be calculated by using the formula P is equal to mgh by T. Power P is equal to 100 into 10 by 20, that is equal to 500 watts. A bob of mass m is suspended by a light string of length L. It is imparted a horizontal velocity v1 at the lowest point A such that it completes a semicircular trajectory in the vertical plane, with the string becoming slack only on reaching the topmost point C. What is the ratio of kinetic energies of the mass at point B and point C is? What are the external forces acting on the bob? Weight mg and tension in the string T. It can be observed that tension does no work as displacement is perpendicular to the string. Total mechanical energy of the system is conserved. Of the bob suspended is m and its length of the string is L. Let the velocity imparted to the ball be given v0. If we take potential energy of the system to be 0 at the lowest point A, at A is equal to half m v0 square. From Newton's second law, it can be observed that Ta minus mg is equal to mv0 square by 2, where Ta is the tension in the string at A. At the highest point C, the string slackens as the tension of the string Tc becomes 0. At C, E is equal to half mvc square plus mg into 2L. From Newton's second law, here mg is equal to mvc square by L. Here Vc is the velocity at C. From the above equation, Vc can be written as root GL. On taking this root GL in the above equation, E is equal to half m Vc square plus mg into 2L will get 5 by 2 mgl. But half m V0 square is equal to 5 by 2 mgl, and simplifying this V0 is equal to root 5gl. But at B, E is equal to half m Vb square plus mg into L, where Vb is the velocity at B. Therefore, half m Vb square is equal to E minus mg into L. On taking this L value here, E value here, 5 by 2 mgl minus mgl, that is equal to 3 by 2 mgl. So half m Vb square is equal to 3 by 2 mgl, Vb is equal to root 3gl. We are taking the ratio of Kb to Kc, kinetic energy at the point B to kinetic energy at C. Half m Vb square by half m Vc square is equal to 3gl by gl, that is equal to 3:1. Therefore, kinetic energy at the point B to kinetic energy at point C is equal to 3:1. A cricket ball of mass 150 grams moving with a speed of 126 km per hour hits the bat at the middle of the bat, held firmly at its position by the batsman. The ball moves straight back to the bowler after hitting the bat. Assume that collision between ball and bat is completely elastic and two remain contact for 0.001 seconds. The force that the batsman had to apply to hold the bat firmly at its place would be. Now the problem seems to be lengthy. Here the concept of force applied is nothing but the rate of change of momentum. Therefore, F is equal to m into v minus u by t. Here, when we convert this velocity 126 km per hour into meters per second, we will get 35 meters per second. F is equal to 150 into 10 power minus 3 kg into 35, because the ball comes to the same point where it has started, that 5 minus 35 minus of minus 35 by 0.001 seconds. On simplifying this, we will get 1.05 into 10 power 4 newtons. Therefore, the force that the batsman had to apply to hold the bat firmly is 1.05 into 10 power 4 newtons. A body of mass 0.5 kg travels in a straight line with a velocity v is equal to a into x power 3 by 2, where a is equal to 5 meter per second. The work done by the net force during its displacement from x is equal to 0 to x is equal to 2 meters is. Here velocity is given in terms of the relation v is equal to ax power 3 by 2, where a is equal to 5 meters per second. The acceleration is nothing but the rate of change of velocity. We know that dv by dt can be written as dv by dx into dx by dt for the sake of convenience. Therefore, v into dv by dx. Once we square the above relation, v square is equal to a square into x cube, and differentiating both sides with respect to x, we get 2v into dv by dx is equal to 3a square x square. Therefore, acceleration is equal to 3 by 2 a square x square. Since force is equal to mass into acceleration, 3 by 2 into ma square into x square. Since we have to find out the work done by the net force during its displacement from x is equal to 0 to x is equal to 2 meters, we have to integrate the relation between the limits 0 to 2. W is equal to integral 0 to 2 3 by 2 ma square x square. Therefore, 3 by 2 ma square into x cube by 3. Since we have to find out the work done during its displacement from 0 to 2, W is equal to 3 by 2 into ma square into x cube by 3. In the place of x we are substituting the limits 2 and 0. That is equal to 3 by 2 into 0.5 into 5 square into 8 by 3, that is equal to 50 joules.